Hey everyone, welcome back to video number 3 of this series. So if you're joining this for the first time, this is just a series of videos I'm doing based on the most frequent consultation calls that I tend to have with people based on my experience with Circus, with acrobatics, but also with my training around the brain and nervous system. So today, we're going to be talking about coordination, how you can improve your coordination and spatial awareness. I've put in the title that it's based around dyspraxia. This is normally the condition that prompts this conversation. I spend most of the time when I'm speaking to people who have got dyspraxia and are looking for ways that they can manage symptoms. Now, just before we get started, I just have one little thing to point out where last week we talked about ADHD, and actually, a lot of the research done on ADHD has kind of been able to pinpoint which regions of the brain are involved, which regions are performing well, underperforming, and because of that, once they know what's causing the problem, it becomes a little bit easier to help find treatment strategies and medications and things like that to help with it. With dyspraxia, no such research has really shown any promise at the moment. We don't really know what it is. We don't really know what specific parts of the brain are targeted, or even if the symptoms everybody is experiencing is being caused by the exact same thing. So we could all have people could have similar symptoms, but actually it could be caused by something completely different. Each thing could be caused by something completely different to each other, and it's impossible to say right now, which one is which. So everything that I'm going to be talking about has been based around what we know about the brain and which regions tend to control coordination. So whether you've been diagnosed or with dyspraxia, or if you just struggle with coordination or just getting your body to do what you want it to do. We're going to be looking at all the brain regions involved, how we might train those so that whether or not we can actually effectively treat it, we can at least see symptoms improve, and we can at least see our ability to perform and learn improve from that. So first one thing that we're going to get into, I'm just going to kind of dive through different parts of the brain and different bits that we might want to be looking at training. And the first one we want to have a look at is a region of the brain called the thalamus. And I'm going to start with this one because 90% of the time when somebody comes to me with coordination issues, some kind of training for the thalamus sorts out a great deal of stuff. So, people usually find they still have to pay a lot more attention to their movement, etc. But a lot of this kind of training is just figuring out what is the smallest chunk we can break stuff down to, and then drilling and training that. So the thalamus, basically, its job is to send information from the body. So all the sensory information that comes in, its job is to send it to the right spot in the brain. So each bit of information is supposed to go to a certain place, and that's the thalamus's job, is just figure out, okay, you know this is sensory information from the right hand, so that needs to go up to the left side of the sensory cortex, and this is information from the eyes, so that's going to go to, let's say, the middle of the cerebellum, or something like that. It's just like pointing and directing everything to the right place. And obviously, you can imagine if that was to start to go wrong, whether it's happening too slow, the information is taking too long to get there, or if the information is going to the wrong place, that would have a significant effect on how you use your body. If it's happening too slow, then you're giving your body a command to something that may have already happened a long time ago. And so the information on the feedback loop that comes back is going to be really, really weird, because it says, all right, you've asked me to do something, but you've asked me to lift my arm up above my head, but it's already there because you told it to do that ages ago as well. Or it could be that the information's going to the wrong place. So you're telling your right arm to move when it's actually your left arm that is the one that's supposed to be moving. Either way, that's going to affect your movement. And there's two fun ways that we can train the thalamus. So number one is based off an idea from an app called Recognize. Recognize was designed to help treat chronic pain patients. They found that when you've suffered from chronic pain for a very long time, your movement obviously is going to decrease. So let's say we've got a chronic shoulder pain. They're not going to move their shoulder so much because it hurts to move. But then because of that, then they start to lose sensory awareness in the shoulder. Because the shoulder's not moving, the brain stops listening to the information coming up. And over time, once they start to try and get the shoulder moving again, it's very uncoordinated and it struggles to, go in a straight line or do what you're asking it to do. And they found one of the ways they could improve this was to get people looking at other people's shoulders and being able to identify really, really quickly whether it was a left shoulder or a right shoulder, or let's say the front of a shoulder or the back of a shoulder. And they would just do that as quickly as they possibly could. And basically what your thalamus has to do when you see somebody else's left shoulder, it sends a signal down to your own left shoulder to be like, oh yeah, that looks like this. Let me just check. Okay, yeah, that's what that is. And so when you have to do it really, really fast, your thalamus has to work really, really hard figuring out, which side of the brain should each of these signals be sent to. Now, the Recognize apps, you do have to pay for, unfortunately, but a really cheap way that you can do this is literally just go on Google Images and just find, search for hands, search for faces, search for elbows, knees, all the different joints in the body, all the different limbs, and just create a little album of all of those. And you can just swipe through that as quickly as you can, calling out left, right. You make it harder, as I said before, like have front and back. So front of the hand, back of the hand, front of the left hand, back of the right elbow, all of that. So just being able to call out the orientation and the correct side can be a really good way to get your thalamus working hard at figuring out which way to send that information. And that can go a pretty long way to improving the thalamus's ability to send information to the brain from your body, which if it's doing that a little bit faster, you probably find your coordination gets a little bit better. The second thing that can happen, though, is in order to have good movement, it's not just your body moving, it's you moving around space. And when it comes to Circus, a lot of the movements that we're doing around space tend to be very, very dangerous. So, if you're really high up, if you're doing some kind of acrobatic skill that involves flying through the air, if your brain does not think it's capable of sending the information to the right place fast enough and precisely enough, then it's not going to want you doing those kinds of movements. And you might find that either you're restricted from doing it, or worst case scenario, you are mid skill, and because your stress levels go up, the thalamus is going to, everything is going to kind of just slow down, and the weakest links in the chain are going to perform worse. So if the thalamus was already not performing so well, then it might really screw up. And then, so when you're trying to kick your legs backward over your head, perhaps they just drop down forwards, or they become non-responsive, and then we end up getting hurt. So if this is the case, one of your best friends is going to be any kind of obstacle courses. And these could be, Ninja Warrior style, or like a playground or something like that, where, you can just have a practice climbing over things, getting under things, and just navigating through space in a way that your brain has to basically unconsciously figure out what to do with your body while you're thinking about the world around you in an environment that isn't super dangerous in the same way that your circus equipment might be. Another way that you could do it is to just start building your own obstacle courses. So sticking, in a bedroom, in an office, something like that, putting loads of obstacles around the room and just seeing how quickly you can get from point A to point B, and walking around, getting over stuff, maybe getting under stuff through tunnels, be super creative. And even better than that, you can also try doing things with your eyes closed. So if you don't want to set up any obstacles, you could just see, all right, well, I know my door is right here. Could I get from my chair to my door and just get my hand onto the handle with my eyes closed? Or if you're, have a desk job, you're working in an office, something like that, could you practice actually just closing your eyes and being able to pick things up straight away? So, look at your pen and you want to get your finger to touch your pen first try. So it's not feeling around, it wants to hit, pick it up. Or, your water bottle wouldn't necessarily use hot drinks or anything that might spill and stain. But, picking things up can be really, really great. Third option, if you've got one of these chairs that spin around, spinning yourself around can be really, really useful as well. So I maybe don't have enough space to do this, but closing your eyes and seeing, can you turn yourself around and stop? And when you open your eyes, you see, have you actually gone a full circle, or have you overshot like I did, or not gone quite far enough? So if you're really bored, or set up a challenge in the office if you're working, and see how quickly you can spin yourself, how many turns you can get where you can always land facing exactly the right direction, and just have your brain thinking about your orientation in space. Final one that could work like that is to with your eyes closed, be able to point. So being able to point to, let's say, the light switch, and then turning around and seeing if you got it. So have a look, close your eyes, point to something in the room, or go and get it. So anything that involves navigating your way through space is going to be really, really useful. Even better if you can be navigating with your eyes closed, because we'll talk about how the eyes can compensate for some other parts of the brain in a little bit as well. After that, if you're finding that these kinds of things are helpful, so you find you've done the left and right recognition and you're not very good at it, you struggle to go through quickly, or if you find navigating obstacles in real life is really, really tricky, then another thing that's a little bit more fun that you might want to incorporate is adding more video games into your life. So any kind of game where you're having to navigate yourself through a course, through space, particularly. So, racing games are always my go-to, because there's an element of speed involved there as well. So you have to make quick decisions and quick thinking. But even, those kind of puzzle games, I remember Nintendo had one, Super Monkey Ball, where you have to navigate a monkey through a ball on a course, and it has to be very precisely balanced, that kind of thing. Any kind of making your way through a maze, or something like that. Better if it's in kind of first person or third person, rather than like a side on what did you call that, Flappy Bird type game. One that puts you in the kind of view of the person can be a lot better. Reason this can be really helpful is, even though it's on a screen, your brain, to understand any kind of visual information, it's always going to start firing neurons in the brain as if you're actually doing the thing that you're doing. So, anytime if I just say lift your right arm up in the air and you don't do it, to even understand what I'm saying, a part of your brain has activated all of the neurons and even some of the muscles that were going to do that. When I put you in a racing game and you start flying through a course at high speed, there's a part of your brain making it real to help you figure out what you're going to do next. So that's why when you see people playing video games, they're twisting and turning and trying to dodge things and lean into things, even though the only actual movement that needs to happen is just from the thumbs. And then that's the second thing that you can do to make this a little bit more effective, is once your body starts trying to do all of these movements, to have a bit more control over the thalamus and like which information is getting sent where, you're going to then try and resist that. So you're going to say, all right, well, actually, I'm going to watch these movements happen. I know that these signals are going to fire in my brain to make my body feel as though it's moving. And then the kind of ultimate control over where these signals are going is to then say, all right, but actually I'm doing the bare minimum of movement. I'm relaxing as much as possible, and I'm only moving with the kind of maximum efficiency, the minimum amount of additional movements going on. That can be a little bit tricky if you've got like a Nintendo Switch where actually there's tilting and stuff built into the controllers. But again, as long as you're keeping it to a minimum, then you're on the right track. So that's the big one. That's taking kind of half the call to talk about the thalamus. But as I said, that really is the kind of number one region when it comes to your body not listening to what you want it to do. Very often that is involved. And if it's not, then the next thing that we can do is just look at all of the kind of sensory systems individually. So anytime, if your body's not listening to you, and if your thalamus isn't the issue, if it's not the information getting sent to the correct places, then it can only ever really be a problem with the sensory input or the motor output. So the information that comes into the brain is either suboptimal, it's not as good as it could be. So if you're kind of example, if you've got really terrible eyesight and really terrible vision, you're not getting the best possible information from your eyes about what's happening in the world around you. If you go to the dentist and they're giving you a filling, they put an injection in your mouth, then suddenly you're going to lose all of your sensitivity on the inside of your mouth. And then when you go to take a drink, you physically can't hold on to it. So you can't control your movements because you no longer have the sensory information to tell your brain what's actually going on. Same thing with the motor output. So with the motor output, really there's not a whole lot you can do. If the motor output isn't good, the brain just eventually figures out and learns how to make it better and better. But all of that relies on the sensory information coming in being good. And if the sensory information is wrong, or it's not matching, so the eyes don't match the touch or the taste or something like that, then that's when your brain has trouble figuring out exactly what's going on. So the next thing that we're going to look at is, well, how can we improve the sensory information that's coming into our brain? Number one thing we're going to want to do, if it's our body that we're trying to get to move better, then again, we're going to be wanting to do more and more movements with our eyes closed. So if you're on your circus equipment and you're training kind of basic skills that you know are not dangerous, then at some point you're going to want to see, all right, how much of this can I actually do with my eyes closed? What's then going to happen is your brain's going to go, actually, usually when I've got my eyes open, my vision is like this great resource because vision takes up about 50% of your brain. If the information coming from my shoulder isn't very good, well, I can make up for it with my eyes. Either I can look at my shoulder and see where it is, or I can see that my arm is here in my peripheral vision, so now I know where my shoulder is. Or even if I can't see my shoulder at all because I'm holding on a bar, well, the horizon that you see in the room, if you're higher up, then you know that your arms are probably bent, so your shoulder is probably pulled down a little bit. If your eyes are lower down and closer to the floor, then your brain can make the assumption that you're probably in a straight arm position. So based on all of the information, you can have terrible sensory information from the body, but if the eyes are working, even if they're not looking at the bit that you are trying to use, the eyes can be a really great way to compensate for that. And that's a great thing that our brains are able to do. It's really cool that just having vision means that we can make all of these adjustments that kind of defy logic. But for your body, if it's not responding to commands very quickly, it could be that actually, your visual system is compensating for your shoulder joint, for example. But now, if your visual system starts to get tired, then suddenly you're going to find now you struggle to move anything well. So just by taking the eyes out of it, and it could just be in your warm up. Do you do shoulder circles in your warm up? Okay, well, maybe doing shoulder circles with your eyes closed is going to be a slightly better exercise. Or like I said, if it's conditioning type stuff, anything where you're not going to be super worried about something unexpected happening and getting hurt, it's probably a good idea to start seeing, can you take vision out of the picture to improve your movement that way. The second part of that is any part of your body that doesn't move well. To be able to move a joint well, you have to be able to feel a joint well. And so you might find that as part of your warm-up, and this is especially with dyspraxia, where we're not sure, I'm talking about things that might help to alleviate the symptoms, but since we don't actually know exactly what's going on, we can't say, we can get rid of this and we can make you feel super coordinated all of the time. So this just might be an extra step that you want to take in something like a warm-up, where you add some sensory stimulation, to your whole body. So the kind of classic one would be just sort of rubbing, like I'm showing you here. You could play with different types of pressure. So, it could be tapping, could be vibration, could be temperature. So have hot things, cold things. Really fun one, if you can get your hands on some calipers or even just a paper clip spread apart, you can find what is the closest together you can tap, where you can specifically feel that these are two separate points. So you'll find on your fingers, it should be very, very small. You should be able to touch and feel distinctly two separate points. On your tongue, interestingly, it'll be smaller still, but I'm not going to use that for this. And then as you go closer into the kind of torso area and down to the lower back, then you're going to have to start getting wider and wider. But if you can train that as just, feel the 2 points distinctly, that can be really useful for improving sensory awareness of that area. The more your sensory awareness goes up, the more your movement potential goes up. So training any kind of sensory stuff can be really, really helpful. And then the second side of that is what you do with the kind of core, the trunk. And I'm not going to be talking about core activation and kind of squeezing your abs or anything like that. I'm a little bit anti core activation. I'll happily explain if people are wondering in the comments. But when we're thinking about our limbs, listening to our commands, the big thing is all of the stuff down the middle. So the spine, the jaw, the tongue, the eyes, the inner ear balance systems, all of those things, if they're not moving very well, then it's going to be very hard to send signals effectively to the arms and shoulders. So, key example being, if my spine is just constantly moving, it's so unstable that it's never in one place, my arms are just constantly going to be swinging around as well. So in order for my body to effectively move my shoulder, it's going to have to figure out not just where my shoulder is right now, but where's it going to be next time I kind of sway. And that kind of sway, if you have any kind of spinal instability, so not talking about rigid bracing, but if your spine doesn't move very well, if it's not capable of moving very well, then you'll find that you've got this sort of resting level of postural sway, and this is a super huge exaggeration, but you can find it out if you just stand up with your eyes closed and bring your feet together, or bring your feet one in front of the other, and just see, do you find that you tend to just be pulled in one direction, or do you find that one part of your spine just keeps breaking and trying to fight as you lose balance? That's a pretty good sign that something in this chain is not working maybe as well as it could. Things to work on there would be spinal mobility, so especially the thoracic spine. As you move this better, then the whole trunk becomes a little bit more stable, but also the spinal cord gets kind of flossed. Spinal cord is going to kind of floss all of the nerves in your body to kind of wake up the muscles around it and improve how quickly the brain can send signals to all of those muscles. And the next one would be the tongue and jaw. So seeing, can you actually smoothly move and control your tongue and jaw? They have really strong connections, again, to this kind of core stability chain. And if you find that your jaw can only judder from one side to the other, that actually you might find improving that makes your core feel more stable. And then actually you find you don't have to squeeze and brace everything so much to be able to feel like it's strong and stable. And then the two big ones are going to be the vision and vestibular system. So every time you move your eyes, your whole body, the rule is your eyes want to go wherever your body wants to go wherever your eyes go. So if your eyes go like this, your body prepares everything to go that way. And so when you're moving your eyes, but you're telling your body to stay here, that requires a lot of muscle activation all around the trunk to stop you following your hand and falling over. And those kind of movements can be split between your eyes moving around, so maybe in a circle, maybe writing your name, whatever, or it could be your eyes staying still and your head moving around. So actually, still counts as your eyes moving, but it's happening in a slightly different way. Any kind of movement, especially balancing with eye movement and head movement, is going to be really, really great for just getting stability in this chain. And again, because your visual system is very often compensating for a lot of other systems that aren't working, if you improve your eye's ability to move and to kind of collect information, that can be really helpful as well. So feel free to search my other channel, Rewire Neuro Performance Therapy. We've got a ton of vision exercises on there that you can have a look at. If you do want to take it a bit further, would highly recommend this little guy. So this is the Neuroband. The band itself is pretty unremarkable. It's just it's wearable, so you can bring it with you for kind of warm-ups and stuff. But we sell it with a course that goes through all different kinds of vision and balance exercises that can be really, really useful. So you can find it for free. Like I said, it's literally just balance, move your head, keeping focused on the target, move your eyes while keeping your head still. Those two things just on their own, if you can train those to get better and be able to maintain your balance, you'll probably find that these improve over time, and actually your coordination improves over time. That one is particularly useful if you find you're crashing into things all the time as well. So if you're constantly, banging into stuff and you don't know why it's happening, very often the visual or vestibular systems aren't communicating well with each other. And so you're getting this kind of, one part of your body thinks it's falling this way, so it gives you a big pull to the other side, even when that's not actually the case. So vision and balance training, spinal mobility training, and smooth jaw training, like left and right, or around in a circle. Haven't learned not to try and talk while I'm doing that. Apologies. And yeah, that's pretty much it. So those are all of the things in terms of coordination, especially when I'm working with people with dyspraxia. Those are the things that usually come up. Those are the things that usually kind of do the trick and improve symptoms. So I'd love to hear what you think. If you've got any questions, once I jump off the live, this will be available. Fire me a question in the comments, or if you'd want to chat about getting a consultation call. At the moment, I offer free consultations. We can do that. If you check out my Instagram, it's Circus Trainer, same as the channel name. You can send me a message there. We can talk through, what kind of options you have before you start spending any money. And if you do think you might be interested in working together as well, we can talk about what that would look like too. So yeah, that's pretty much bang on my 30 minutes. So I'm going to let you all go here. Thank you very much for coming to that, and I will see you in the next one.